You stuffed 108 envelopes in 45 minutes. At this rate, how many envelopes can you stuff in 2 hours? What? I don't want answers mean nothing.
No, we're going to tell you how to do it.
Oh, you're just getting right to the real question. I like that. Okay. Give me one word for description of how you're gonna do this.
Ratio.
Go. Ratio. I like that. How many envelopes?
108.
How many minutes?
5 equals x over 120.
Yeah, there you go. So then what 2 words. What do I do next?
Cross multiply.
Oh, look at that. Then cross multiply. I like that. Excellent. So you have 45x is equal to 120 times 108. X is equal to 120 divided by 108. I'm showing you how I would simplify this without a calculator. I divide by 5, and I get 24 times 108 over 9. I divide by 3, make it 8 times 108 over 3. And then I divide everything by 3. 3 to 33, 36, right? 8 times 36. And I'd get 240 plus 48, which is 288. That's what I would do if I didn't have a calculator. Can you follow what I just did there?
No.
Here we go. Ready? Here it is. Look. Ready? Ready? Are you okay with how I got to here?
Yeah.
Okay. What's 100? I look for common factors. What's 120 divided by 5? 24. What's 120 divided by 10?
12.
What's 12 times 2?
24.
You just divided by 5. What's 45 divided by 5? 9. So I divided the top and bottom by 5. So I divided by 5 over 5. What's 24 divided by 3?
8.
What's 9 divided by 3?
3.
Divided by 3 over 3. And then 108 over 3 is what? You have to recognize that's probably the trickiest part. That's 36. And then how did I do 8 times 36? I did 8 times 30 plus 8 times 6 to get each of those. I broke it down to smaller pieces. Break things down to smaller pieces. It goes. You can do it without a calculator. So to reiterate, kids, I like this first step. If you did this first step, it makes it a heck of a lot easier. Heck of a lot easier. That's fine. Another advanced first step would be to or multiply by, what's a quicker step, multiply by what? Instead of multiply by 3/5. So you multiply by 3/5, you immediately go to the 5/3. You just have to multiply -10 by 3/5. Break it down into simple steps. 4 simple steps. Absolutely, you can cover this. 3. Now, someone raise their hand and tell me what I should do next. What should I do next? Simple. Yeah, what should I do?
Minus.
Subtract or what?
Subtract 7.
Nope. Close.
Add 7.
Add 7y to both. I like that step. Sure. And you end up with what? Negative 2y minus 6 equals 3. Now what? Add 6 to both. You like my color usage there? Oh, that's pretty cool. And my handwriting gets terrible. Yay. Negative 2y equals 9. So y is equal to... Yeah, I like putting the negative on top. In general, it's more common. Doesn't change anything. You can just put it on top. That's fine. If I have a certain amount of money and I want to increase that amount by 8%, so I have a certain amount of money and I want it to grow 8% bigger, what do I multiply by?
The percent you want to 1.08.
Yes, you multiply by 1.08. If you multiply just by 0.08, what have you done?
You're going backwards.
You've reduced it in size by 92%. There was actually a typo in a bill that was actually voted on in Congress. They got the sentence wrong. That was the core of the bill. This was recently, a couple months ago. And it basically was like, such and such a thing will only happen if unemployment reaches a certain percentage, right? They forgot the un in front of unemployment. So instead it meant employment. So it reversed the percentage. So instead of like kicking in at 8% unemployment, it would kick in at 92% unemployment. It was something like that, right? And it actually got, they're like, we need to change this. And you can't just scribble something out. To change a bill, you have to vote on lots of things again. But it was totally ridiculous because the way it interpreted was like, when unemployment reaches 92%, you know, people are just standing outside counting clouds, you know, which maybe could be a job. So to grow something by 108, to grow something by 8%, you need to multiply by 1.08. 1.08. So what equation can you solve? You started out, the starting amount of money, what do you want that letter to be? X. You take X and you multiply it by 1.08. X plus what? 0.94. Exactly. There's the equation you solve. What should I subtract from both sides? X. And you end up with 0.08. X is equal to 0.94. So X equal to 0.94 divided by 0.08. Anybody have the answer to this? 11 point what? So before the increase, it was 1175. Many money problems are much easier than they seem, but the careless mistakes result in answers that just don't make sense. Always, when you're dealing with, especially with money problems, but any math problem really, check reality, right? If you multiply by 0.08, you would end up with, I think, a negative number into it, because we don't have the math to do the detailed questions that I would like to. But what's the difference? You understand what interest is, right? We talked about that yesterday. There are two basic types of interest. There's simple interest, which is what that problem we did yesterday was in, simple interest. There's another general type of interest. Begins with a C.
Complex.
I like that, complex. Compound interest. Does anybody know what compound interest is?
Does it like keep building? Like,
It keeps building.
Years,
No, it keeps building.
Goes up?
Simple interest. You can have an account with simple interest that keeps building, but you can also have an account with compound interest. This is the one that happens in real life. Simple interest doesn't really happen that often. Simple interest is way too simple to model the real life. So if I put money into a bank account and you earn interest on the money you put in a bank account, correct? Where does the interest go? It goes back into the bank account. When you earn simple interest, you only earn interest on the principal, which is the amount in the account. So if, let's say I had an account with $100 and I earn 10% simple interest every year, how much more money goes into the account every year? $10 is added in, $10 is added in, $10 is added in. So look, $100, right? You add in $10 and you get $110. The next year, how much starts there? $110, but what do you add in? You still add in 10, what do you have? $120 at the beginning of the third, you add in 10, you get 30. So this is simple interest, okay? Compound interest, you started with 100, you add in $10, and you end up with 110. You start with $110, what do you add in this time? $11, and you get 121. The beginning of the third year of 121, what do you add in? $12.10, and you end up with 130 what? 130.1. And then just do one more year here. You start out with 133.1. What do you add in? 13.31. It's 10% of this. Oh, and then how much at the end of that year? 146.41. We're doing addition. So anyway, you do interest on, here's a good word for you, accrued gained interest. Here's the thing. The reason it's done this way is because where's the money go? Yeah, why wouldn't you get interest on your money? Is there you have money or you don't have money? It's going to go up like this. It goes up like this. It's a more accurate way of modeling reality. It's a much more what? Exponential. It's an exponential function. That's correct. This is an exponential function. This is a linear function, and this is an exponential function. Exactly. So that's the difference functionally. I just want you to understand that difference. You generally see compound interest. And just to talk about this a little